My name's Dana Batipka, as he said, and today I will be talking about some work that my colleagues and I did titled Hackers versus Testers: Comparison of Software Vulnerability Discovery Processes. So anytime a new piece of code is written or modified, it's important that it be checked to make sure that the developers didn't introduce any new vulnerabilities. So who's actually involved in this process? Well, basically anytime we're talking about a bug, this is your software tester is going to get involved. They're looking for anything that could be a functional problem, a performance problem, or what we care about most here, a security problem. However, they generally don't have the level of expertise necessary to find these kind of issues, so companies start to reach out to experts in this area, also known as white hat hackers, by bringing them either in on their internal security teams through contracted penetration tests, or what's become popular recently, reaching out to the crowd of hackers through bug bounty programs. Now, while this approach has yielded a lot of interesting vulnerabilities, there's still some challenges with sort of having an expert-based review. One of those is sort of the timeliness of this approach, because there's a small number of these experts. These reviews generally don't occur until later on in the development process, and the longer that you wait to sort of fix a vulnerability, the more costly it is. Additionally, there's a challenge with cognitive diversity, because again, there's a limited number of experts. You have an issue here where there's a limited number of ideas or perspectives brought to the table, and this is important in these kind of problems where it's kind of like a needle in the haystack issue. Additionally, for communication, something we see especially in bug bounty programs is there's generally a low signal to noise ratio. So in order to start to approach some of these problems, we first really need to understand the ecosystem and sort of figure out how these people who are involved actually go about this process. And that sort of brings us to the research questions of the study. So how do testers and hackers search for vulnerabilities, and what are the differences between testers and hackers? And the reason we ask this second question is really to understand what sets hackers apart, and also is there anything that we could learn, or one population could learn from the other. Now, to sort of start to answer some of these questions, we ran an interview study where we had participants perform a task analysis over their vulnerability discovery process. And this is a sort of standard technique which is useful for helping experts consider some of the more subconscious parts of their process. And additionally, throughout, we also asked participants to talk about the different tools they use, the skills they found important, and the communities they were part of, so that we can get an idea of what actually went into each of these tasks and how they sort of developed the necessary skills to perform them. To recruit for this study, we reached out to a number of organizations associated with these two populations. Here we show a list of, or some of the different types of organizations we contacted, and for each we reached out to their leadership, talked about our sort of motivations and goals for the study, and asked them to recruit their members on our behalf. And in total, we contacted 106 different organizations globally, and from that we eventually interviewed 10 testers and 15 hackers. The reason we have less testers here is that we reach saturation of ideas sooner with our testers. Additionally, as you'd kind of expect, our testers reported finding less vulnerabilities on average, so 0 to 3 on average, as well as spending less time looking for vulnerabilities. Also, our participants came from a variety of different backgrounds, with our testers coming from companies in a variety of industries, with companies being as small as 50 employees to thousands of employees, and our hackers performed a variety of different roles in sort of their normal life, being some penetration testers, some doing bug bounties full-time, and others doing it sort of part-time and being developers or sysadmins as their full-time job. So what did we learn from sort of these interviews? Well, going to our first question, what's their process? We found that both our testers and hackers actually performed a similar process. And sort of these 6 steps outline sort of the different ways that we saw our participants sort of carry out this vulnerability discovery process. So they began by basically trying to get as much information about the program, develop some context, sort of understand some metadata, looking for things like what libraries does the program use, what's the update history, what's the new code, what's the older code, what previous bugs have been reported. One of our testers explained sort of this last bullet saying there were other functional issues, so I figured that was probably where there was the most likely to be security issues as well, because bugs tend to cluster. And so this process is basically just trying to figure out where to begin focusing on. Next, they move into sort of the main loop of their process, which is all about understanding how the program works and sort of exploring it. And this begins with the program understanding phase, where they're answering questions like, how do the different components of the program interact? How does the program interact with its environment? Things like the OS, the network. And one of our hackers explained this, saying you're touching a little bit of everything, and then you're organizing that into a structure in your head, basically trying to create a map of how the program functions. Then they move into the attack surface phase, where they're basically trying to find all the ways that they can manipulate the program, either through direct means, where they're actually just interacting directly with the program, or maybe they do some other actions that are later used to manipulate the program through an indirect mean. Then they begin to explore the program by providing different inputs. This can either be by providing an input and fuzzing the program, seeing what it does with different types of inputs, or looking at how that program in the code handles those inputs. And then this process sort of continues on. The exploration phase feeds program understanding, allowing them to find a wider attack surface and explore deeper in the program, until eventually they find a vulnerability. And they described this phase as being heavily intuition-based. And what we found that they meant by that was that basically they see something that looks like a problem that they'd seen before. So the code looks similar to a vulnerable piece of code, or maybe it behaves in some way they didn't exactly expect. And they start to dig into that and see if they can find a way to exploit it. Then eventually, once they confirm that they found a vulnerability, they have to report this to the developers so that they can actually make a fix. And our participants stressed that a large portion of this was sort of advocating for why this problem needs to be resolved. And so they sort of emphasized making sure the reports were understandable or readable, and pointing out the impact of not fixing this vulnerability. One of our testers explained this, saying, you do have to convince someone that there's a risk. It's quite timely or time-consuming running a ticket. Now that we've seen that they have a similar process, how do these two populations actually differ? What we found is that there were actually 4 sort of factors that led into how they actually carried out these processes. The first being their vulnerability discovery experience, which is basically the different vulnerability discovery engagements they've been involved in, or stories they'd heard from other people about their experience. Their underlying system knowledge, or how well they understood things like how the operating system handled memory management. Their access to the development process, if they were actually regularly communicating with the developers, they were able to see internal documentation. And finally, their motivation. Why were they actually looking for vulnerabilities in the first place? And this could be either to find sort of the biggest impact problems, or looking for basically the simplest bug they could get so they get a quick payout. Now, what we found is that the biggest differences between our two populations was really in their vulnerability discovery experience and their access to the development process, with hackers having more experience and testers having more access. And for the rest of this paper, we're going to focus on these 2 specific aspects, or for the rest of this talk, we'll focus on these for brevity, but the other factors and how they affect this process is included in the paper. So what we found is that for their experience, this had an effect on the attack surface, exploration, and vulnerability recognition phases. And in the first 2 phases, their prior experience sort of gave them different ideas and things to try when looking at the attack surface and running the program. One of our testers explained, or gave an example of this, saying, as soon as I found the LinkedIn problem, I made sure to test Facebook and Twitter input to make sure that they were processed correctly. And if they did allow login with a third party in the future, I would check that too. So the idea here is basically they saw this sort of indirect input path and they made sure to try it later on. This experience also helps them sort of develop the intuition that we found was important in the recognition phase, by helping them come up with different patterns to look for of things they'd seen previously, as well as a list of common vulnerabilities to check for every time they sort of look at a new program. Now, we found that our participants learned this experience through just their employment, their day-to-day job, through hacking exercises, things like capture the flags, or just work training exercises, by talking to other people in their community, and then finally by just reading bug reports. Now, what we saw is that both of our participants, or both of our populations, learned through all these mechanisms, but the real big difference was in the amount of experience that our hackers had. For example, our hackers were generally looking at many different programs from a variety of different companies and regularly switching between them, whereas our testers were only looking at maybe one program within their company. Our hackers were also generally reported participating in tens of different exercises, whereas our testers only ever participated in maybe one or two, and the ones that they described to us generally only exposed them to a very few number of different vulnerabilities. When it came to their communities, our hackers talked to other hackers who had more experience, whereas our testers maybe only knew one or two other people who even were interested in security. And then finally, when it came to their bug reports, our testers were generally looking at just reports with internal to their company, whereas our hackers were looking at a wide number of reports from a variety of different sources. Okay, so we know that our hackers have more experience. What we found is that our testers, because they're generally more ingrained into the development process, they have more access. And this is important in both the information gathering and program understanding phase because they're able to talk to developers, read internal documentation. They kind of have a head start in understanding how the program works. However, this can be a double-edged sword because as they talk to developers, they might begin to adopt some of the flawed assumptions that actually led to these vulnerabilities. One of our testers explained this, saying it's hard to ignore certain details once you know about certain areas already. Now, where this access really was useful was actually in the reporting phase. Our testers are sitting next to their developers. They're regularly communicating with them. They're talking with them about a variety of different bugs. One of our testers explained this, saying you can get feedback to your developers, you're coming back with information, and they react on it. And through this sort of back and forth communication, they start to develop a rapport and a shared language. Then whenever they find a vulnerability, they have that shared language to communicate, whereas our hackers, because they're maybe only reporting a few bugs or a few vulnerabilities, they don't have this sort of shared language, and you sort of have this barrier. And so they generally reported focusing on spending extra time developing exploits, and these sort of had mixed results if the developer actually understood what was going on. So to conclude, I'll just leave with some recommendations from our paper that are sort of most salient. So first, talking about the testers, we know that they don't have the same level of experience as our hackers. So in order to help them sort of develop some of this experience, so we can get more eyeballs that are sort of experienced looking at these problems throughout the development process, we recommend providing training in a known context. So within the context of their work, so that they don't have to learn a new system, they're just focused on learning about new vulnerabilities. One recommendation would be to hire one or two hackers to come work alongside the testers, work alongside them, tell them about their different experiences, point out problems. Then those testers learn from the hackers. They then share that with other hackers, and the company eventually starts to develop a sort of culture of security. And we actually saw some success stories of this that were given by some of our testers. Another opportunity would be to provide sort of bug report-based exercises, so similar exercises to those that our hackers reported participating in, and just using sort of vulnerabilities that have already been discovered in a system or in a code base for the company, using the diff prior to the fix, and then basically having the participants trying to find the same vulnerability. It gives them hands-on experience while also not having to learn a brand new system. Then looking at the hackers, we know that we need to help them develop this better relationship, and one way we think we can do that is providing a single point of contact and having companies make sure that either one person or a small team of people are involved in providing this feedback to hackers whenever they're communicating. This will allow whenever a hacker reports a vulnerability, if they report multiple, they start to build this shared language. And even if they're only reporting one, you have a single point of contact. You're starting to learn these hackers' language and be able to sort of translate for the developers. So in summary, we found that both populations had a similar process that was impacted by their vulnerability discovery experience, their underlying system knowledge, access to development process, and their motivation. And the biggest difference between these two populations was their amount of experience and their relationship with the developers. And so we provide a few recommendations to help testers gain more experience and our hackers to help develop their relationships. With that, I'll close for any questions.
So we do have time for questions.
I was sort of wondering about the relative amount of time and whether it be cost effective for a company to put as much work into finding vulnerabilities as a world full of hackers do.
So you're saying basically should a company focus on this as opposed to just pushing it out to a bug bounty program or something and letting anyone look for them? Is that?
I'm not saying that.
No, I
But
agree.
but-
I'm just
but
asking that question.
A company has to determine how much time and effort they're going to put into polishing a product, and all software does have bugs.
Mhm.
So do you have a concept of the amount of, what it would cost a
Mhm.
company?
Yeah, so I mean, these recommendations that we provide here, just hiring a few hackers or things like that, they're not sort of heavy lifting. And I would also argue that the cost of sort of waiting for a vulnerability to be found by a bug or by a bug bounty program is also going to be a heavy cost, because now you have to sort of refactor all your code and make major changes. I agree that there's sort of this cost-benefit analysis that needs to be done, but the recommendations that we give aren't necessarily sort of heavy lifts in and of themselves. It's sort of developed over time with this experience.
I had one other question. I think I missed something. You were talking about having testers sit next to developers, or at least be in the same environment. I didn't understand if you said that was overall a good thing or if it had some sort of flaw.
So it's kind of mixed. I wouldn't say that it's good or bad. There's definitely benefits of having people such as hackers who are external to the whole process, sort of doing an additional review over top of it, but it can also be beneficial having people actually know the system, know where problems could have existed, they can get to things a little bit faster. So I think having a mix is actually the best.
I've seen many examples of what's similar to cockpit voice recordings that show a plane about to fly into a mountain with the co-pilot saying, "Sir, I think we're going to fly into a mountain," and the pilot saying, "Okay, we're clear of that airspace," and the co-pilot saying, "Sir, I think we're flying into a mountain." I have seen that happen in software development, where a tester will say, we're getting a port connection that I think is dangerous, and the developers will say, that cannot happen. I know the code that prevents that, and it cannot happen.
Yes, and that's kind of where sort of these developing exploits and sort of proving this. I mean, even our testers sort of stated that they would try to prove that there were problems, that they still had this communication issue. Generally, it was less so stated than our hackers who are completely external to the entire process. So, but yes, that's still a problem.
Jason Lee, Intelligent Automation, interesting work. Congrats, and Michelle. So, I have a question related to our own experience. When you talk to hackers, we have found lots of hackers, they are not so awesome. They think they are totally awesome, and vice versa.
Yep.
So what do you think that kind of a situation might impact your results or insight to the community? And is that a variable that's critical?
Yes, we definitely had participants who believed that they were awesome, who maybe didn't know what they were talking about. We weren't necessarily we didn't measure exactly what their success was. We were more just asking them about their process, asking about how they did things, and had them break that down. So that sort of comes out in the wash whenever you're sort of just talking about how do you do things, because they can't explain these more complicated ideas if they don't actually do those sort of things.
But would any of those impact your results?
So again, we're not actually measuring the level of success, or like we don't actually look at do they find these vulnerabilities. We're more talking about how they describe this.
Understand. Yeah, we can talk offline. Thank you.
Okay, yeah, absolutely.
So we do have time for one more question. Either of you, please say your name and affiliation.
Patrick De Silva, Newark, Newport. A quick question regarding the community of testers that you were seeing across various companies. Did you see a correlation with regards to companies that supported community of interests around hacking and cybersecurity, and creating an awareness to bugs are out there and cybersecurity is a big problem, correlated to how successful or how well their testing community or how they were doing with finding bugs in their software?
Yeah, so I wouldn't necessarily say about the company's priorities, but we definitely talked to our participants about like what communities they were a part of. And so they discussed things like they were a part of things like Ministry of Test, where they would go and learn about these hacking exercises from an organization that's kind of knew about these security problems. And the people who were more involved in these sort of security interested groups tended to be the ones who had more of this experience, who would be better at finding these problems. Also, because this is an interview study where we told people that we were asking them about security, we tended to get people who were more interested in security. That being said, we kind of had a wide array of whether or not their company was actually interested in security or whether or not they supported them. Generally, that was not true.
Thank you.
Yep, no problem.
Okay, let's thank Daniel again.